Hello class, welcome to the Stat 215 Introduction to Probability and Statistics Lecture 1 video. Before we get started, let's cover the basics of this course by going through our syllabus. You can find the syllabus posted on eCampus. You can also find it posted on MyStatLab, which we will go into more detail as we go through the syllabus and information located on eCampus. So once you log on to eCampus and select My Course ID, the first thing that should pop up is the announcements. So I'll take a moment and go into the student preview mode. So right now there are no announcements posted. By the time you're watching this video, there might be, but currently as I'm making this video, there isn't. Under course content, you will find several folders. The first folder will have your course information, which includes our course syllabus and the MyStatLab registration. So starting off, looking at our course syllabus, again, this is Stat 215. You have My Instructor information. Best way to reach me is through email. I will leave you to read the course description. I do want to highlight your required materials. MyStatLab student access code for electronic access to our learning system, and the e-textbook Probability and Statistics for Engineers and Scientists, MyStatLab Update, 9th edition by Wellpool, and you have your ISBN number. Our publisher is Pearson, and you will need an individual access code. That code is going to be service 33824. I'll give you more information from this when we take a look at the MyStatLab registration. So again, I'll leave you to read the GEF course information, the student learning outcomes, and drop down to talk about the grading. So I give 2 exams, quizzes, and homework for this course. Your midterm exam is worth 30% of your grade. Your final exam is worth 30% of your grade. You will have 4 quizzes. Each of those quizzes are worth 5% of your grade. And then you will have 10 homework assignments, and so they will be each worth 2% of your grade. I do guarantee a 90, 80, 70, 60 scale for recording your course letter grades of A, B, C, D, and anything below 60 is a failing grade. So to go into some little bit more detail, your exams, there are 2 cumulative exams that are given over the course of the semester. Each exam will be taken on the Pearson website, and no makeup exams are given. Late exams are subject to a 50% off per day deduction. And to be clear, if the exam is due at 11:50 a.m. and you submit it at 11:51, it is late and it is subject to the 50% off penalty. Next, we have our quizzes. Again, 4 quizzes will be given during the course of the summer session. Each quiz will cover the material that we covered during that current week. Quizzes are given on the weeks that no exam is due. No quizzes will be dropped, nor any makeup exams given. Late quizzes are subject to a 25% off per day deduction. It's the same hard and fast rule as with exams. If you're 1 minute late, you are late. But I am a little bit nicer about how much percent or the amount of percent I take off. So just to be clear of the flow of this course, the first 2 weeks of the course, you'll have a quiz each week. 3rd week, exam, quiz, exam. Homework, again, 10 homework assignments will be given during the course of the summer session. Each homework assignment will correspond to 1 chapter in the textbook. 1 homework assignment will be dropped before the final course grade is calculated. No late homework is accepted. I will leave you to read the academic integrity, social justice, and about disability services. Let's take a look at our tentative schedule of reading, assignments, and examinations. So again, this course is 6 weeks long. In the first week, we are going to ideally cover the first 3 chapters of the textbook. You will have a quiz on chapters 1 through 3, and you will have 3 homework assignments due. next week, week 2. Ideally, we're going to cover chapters 4 and 5. So you'll have a quiz on chapters 4 and 5, and homeworks 4 and 5 will be due. Week 3, we'll just cover chapter 6, and you will have your homework 6, and you'll also have your first exam. Week 4, you will have a quiz on chapters 8 through 9.11, and you'll have your homework 7. That'll cover chapter 8. Week 5, quiz on chapters 9.12 to 10.9. Homework 8 will be due. That'll cover chapter 9. And then the last week of class, you will have homework on chapters 10 and 11, and then your final exam. If you have any questions, please feel free to email me. Again, that is the best way to contact me. And now at this time, let's go back to our course information and take a look at my Stat Lab registration. So this changes every course, so make sure you look at your registration page. The numbers may be different. But the process for getting your e-textbook, you should go to pearson.com/mylab. Under Register, select Student. Confirm you have the information needed. Select OK, register now. Input your course ID. Again, make sure you use the course ID on your course information, My Lab registration. It may not be this exact number. Enter your existing Pearson account username and password. If you need to create an account, please do so. You are going to have to pay for your course using a credit card or PayPal. You can get temporary access, but I believe that only lasts for 2 weeks. So you will definitely have to pay for this course at some point. Once you get signed in and registered, you will have your textbook and access to your quizzes, homework, and exams. So it is very important that you register as soon as possible. All right, so going back to our eCampus, that was our course information folder. Next, we have our lecture slides and videos. You can see we have a folder for each week. Week 1 will have all of the slides and videos you need to watch for that week. Under Tools, send email. You can do this to send email to other people in your class or myself. You can check your grades and take a look at the class roster. That's about it for eCampus. Again, any questions, please email me. So now that we've taken a look at our syllabus, we can start getting into a little more of the organization. So on eCampus, just to review, that will be where your lecture slides, lecture videos, and your gradebook's located. On mystatlab.com, that's where you'll have your electronic textbook, your homework assignments, quizzes and exams, and your StatCrunch. So just to give you an idea of what my Stat Lab looks like, this should be your login screen. You'll sign in. My view is going to look a little bit different because I have the instructor view. And here's where you would need to enroll in a course. Enter my course ID, your email address, and your pay information. And so let's take a second and go back. And I want to show you what your eCampus. your stat lab will look like once you register. You're not going to see these 3 windows to your right, but you will see the probability and statistics for engineers. You'll select on that once you've registered. Sometimes it takes a few seconds to load. And you'll have announcements. It'll talk about your current grades in your class, assignments that are due. Along the left side, you'll see a bunch of options. This is the second place where you'll be able to find my course syllabus. I also made a separate tab for the course schedule, your assignments, the grade book, StatCrunch, which we'll use more further in the class, and your e-textbook. I warn you, sometimes the Pearson website can be slow. You just have to be patient. And there it is. Your entire textbook online. Okay, so I think we got through most of the stuff we need, at least to get us through this introduction. So let's start going into the meat of the class and talk about actual material. So to start off, to talk about a course on statistics, we need to define it. So for the discipline of statistics, statistics singular is the science of collecting, organizing, and interpreting data. Next, we care about a structure of a data set. So information is collected on subjects. A variable is a characteristic that differs from one subject to the next. For example, age, grade level, number of hours you study, and score on a final exam. The values of the variables that we obtain are the data. All of the information collected forms a data set. So, just to review, we've defined statistics to be the science of collecting, organizing, and interpreting data. With our data, we have information on subjects, variables, and how we have our data organized. So, bringing into our first part of our definition, organizing data. So if we look at some of these hypothetical values that, say, Amazon might collect, we can try to guess what they represent, but it's pretty hard because there's no context. We don't know what values are measured, we don't know anything about them, so because of that, looking at this data the way it is, it's pretty meaningless. But if we organize the data in a more logical fashion, we can make our meaning clear. And so now we can see that we have purchase records for album downloads for downloaded albums. The column titles tell us what has been recorded, and each row is going to be a particular purchase. So within each of our table, well, I guess in this case just our one table, we've got our rows, we've got our columns, and inside our rows and columns we have our data. Now to go further into our data, we have our variables, and again, that is a characteristic that differs from one subject to the next. So defining different types of variables, first we have a discrete variable. That tells us what group or category a subject belongs to. Some synonyms you'll hear me use for discrete variables is nominal, qualitative, or categorical. Some examples of these are academic major, country of birth, or blood type. Another type of variable is continuous variables. This contains measured numerical values with measurement units. Some synonyms you'll might hear me say is quantitative variables, or just quantitative. Typically, this records the amount or degree of something. So some examples might be ounces, dollars, degrees in Fahrenheit or Celsius. The third type of variable we're going to pay our attention to is ordinal variables. Ordinal variables are a variable that reports order without natural units. So, for example, you sometimes have that 5-point scale of that strongly disagree, disagree, neutral, NA, agree, strongly disagree. Olympic rank, gold, silver, bronze, and sometimes we treat quantitative by using our rank number. So we say on a scale of 1 to 5 or 1 to 10. That is ordinal variables when we give something in order. So using our data and our different types of variables, we're going to transition to how we are going to visually represent that data. So before we do that, let's just take a summation of what we've done so far. So, data, once again, is information that we have collected about some sort of subject. That data can be categorized into different types of variables. So looking at our organized data set, we have names. Names would be an example of a discrete variable or a categorical variable. Price, on the other hand, would be a continuous variable. Ordinal variables, we could use that to say our order number. Or if we had more of a review scale, which is not in this data, but hey, how well did you like the album? We would have had that as an order scale. So our star reviews would be an example of an ordinal variable. So now that we know we've got our 3 types of variables, they all have their place in our data and understanding. Now we need to talk about how we can visually represent that. So to start off, we're going to think about frequency distributions. So a distribution is the way in which a variable's values are spread over all possible values. Discrete variables have values that are categories. The frequency of a category is the number of times it occurs in the data set. The frequency distribution is presented in a table that gives the frequency for each category. So, for example, if we have a computer retailer that compiles a list of the types of computers sold to the last 50 customers, he may say, all right, we've got desktops, laptops, notebooks, and tablets. And he records the number of customers that bought each of those 4 categories. This is a frequency distribution. We have a frequency distribution table. Now, along the same lines of our frequency distribution, we have something called the relative frequency distribution. Now, this provides the proportion of observations in a category, and again, that is called relative frequency of the category. So if you use your hand to cover up that last column, you'll still see that same frequency distribution that we saw on the previous slide. Our relative frequency takes the frequency we have in our second column and divides it by our total to give us a percent. Depending on what type of information we're trying to gather, we may want the pure frequency or the relative frequency. So still going along with different ways we can represent this data, probably one of the most common ones you're familiar with is a bar graph. A bar graph is a graphical representation of a frequency distribution, rectangles of equal width with one rectangle for each category. Heights of the rectangles represent the frequencies or relative frequencies of the categories. And we have space between each bars. So using that same shopping data, we have two bar graphs, one with the frequency and one with the relative frequency. You can decide which one you feel is easier to understand. Personally, I think frequencies bar graph is easier to understand than the relative frequency bar graph. If I'm doing relative frequency, I might choose to do a pie chart instead. So a pie chart is a circle divided such that each wedge represents the relative frequency of a particular category. For example, if a category has a relative frequency of 0.25, then its sector takes up 25% of the circle. So using our same data before, if we're trying to understand the percent of sales that are, say, laptop, a pie chart is going to be easier to tell that information, and we can easily say, oh, 40% of sales are laptops. And you guys know that with things like Publisher and Excel, we can make our bar graphs and our pie charts a little bit fancier. So still continuing on with the frequency distribution in classes. So to summarize, continuous data graphically, we can divide the data into classes. Classes are intervals of equal width that cover all values observed in the data set. I want to say that again. Classes are intervals of equal width. I want to emphasize that equal width that covers all values observed in the data. For example, the distribution of ages for those aboard the ship Titanic. So this comes to us a bit differently than our previous information, which were discrete variables. With continuous variables, we have ranges. And instead of using a bar graph or a pie chart, for continuous variables, we tend to use histograms. So a histogram is a graph that displays the distribution of quantitative data or continuous data. Notice that you have no gaps between bars unless 0 observations are in that class. Which, if we pull up and look at our histogram data for the distribution of ages in the Titanic, there are passengers at every age category up to 74. But if hypothetically speaking, we had somebody in their 90s, we would have had a gap and then another bar. So one important topic we need to think about is choosing the bin width. So different bin widths may tell different stories, and we need to choose the width that best shows our important features. So if we take a look at these two frequency distributions, still using our Titanic data set, the first graph onto our left has those bars representing every 2 years. So passengers from 0 to 2, 2 to 4, and so on. However, if we look to our right, each of those bars represent every 20 years. Depending on the situation, we might find different graphs more useful. So, meaning if we want more detailed information about the age range, we may find the graph on the left more useful. If we just wanted a simple, hey, what was the greatest age range of people on the Titanic, we might find the graph on the right to be more useful. Now, histograms are a pretty important thing in statistics. We often use them to make assumptions and to analyze our data. So understanding how to interpret histograms is pretty important. So one thing to recognize is when we have an approximately symmetric histograms. So a histogram is symmetric if its right half is a mirror image of its left half. Very few histograms are perfectly symmetric, but many of them are approximately symmetric. Remember, in real-world data, things rarely work out perfectly, so the idea of having your right and your left be perfectly equal, it's probably not going to happen, but you can get it pretty close. We also have situations where your data can be a bit skewed, either to the right or to the left. A histogram with a long right-hand tail is said to be skewed to the right or positively skewed. A histogram with a long left-hand tail is said to be skewed to the left or negatively skewed. This idea of skewedness can get a bit confusing, so I tend to remember it with a little rhyme. So if you're taking a look at our right skewed, I think to myself, ski right, skewed right. If I'm a skier at the top of my mountain, which way am I going to be going down? Well, I'm going to be skiing to the right. Ski right, skewed right. Same thing with the left. Ski left, skewed left. Just a little jingle to remember your skewedness. So one more time for review. Ski right, skewed right. Ski left, skewed left. This means that our peak is to the left or right of center. Next, we're going to pay attention to our modes. You may remember that term from learning mean, median, and mode. So modes are that number that occurs the most. Well, for us now with a histogram, a mode is a peak or high point of a histogram, and a histogram is unimodal if it only has one mode, and bimodal if it has two distinct modes. So for our unimodal, that is our mode between 6 and 7. For bimodal, we have our two distinct modes or towers. Let's do a quick example. So right now we have a histogram of current salaries. On the y-axis we have frequencies, and then on our x-axis we have our current salaries. So first off, is our histogram symmetric or skewed? Hopefully you took a second to think about that and realize that it is skewed. But now, is it skewed right or skewed left? Think of our jingle. Well, you couldn't remember. We are going to the right. So this is skewed right. Next, is it unimodal or bimodal? Well, how many towers do we have? How many peaks? 1 or 2? Hopefully you realized that we were looking at a unimodal situation. There is only one top to this mountain. Okay, so let's pause and looking at our different visual representations, and let's talk about some of those basics I mentioned, the mean, median, and the mode. Let's start off with the mean. So sample mean. Suppose the observations in a sample are x1, x2, all the way to xn. That means our sample mean, which we are going to denote as x bar, is equivalent to the summation of all xi's over n, or equivalently, x1 plus x2 plus ... all the way to xn, all over n. When we're dealing with statistics, n represents the sample size. At this point in the class, you may consider getting a piece of computer paper or notebook paper and writing down what all of these symbols mean, particularly if you're not familiar with them. So knowing that anytime you see the variable letter n, that's going to mean sample size. And if you're not familiar, this funny looking E is summation. That means we add. And X bar or Y bar, anytime you see a lowercase letter with a bar over it, that is going to denote a sample mean. Let's take a look at an example. So you have 5 quizzes in your biology class, and you score 78, 83, 92, 68, and 85. Find the mean score. So we will add up 78 plus 83 plus 92 plus 68 plus 85, and we will get 406. Now our sample size, that is our number of data values, or number of observations, and we have 1, 2, 3, 4, 5. So n is going to equal 5, meaning we will divide our summation by 5. 406 divided by 5, we will have a sample mean of 81.2. Hopefully that was a review for you. Next, let's take a look at the median. So the median, another measure of center, splits the data in half. Given that the observations of a sample are x1, x2, all the way to xn, we arrange it in increasing order so that the sample mean is 1/2 of our xn over 2 plus x sub n plus 1 divided by 2 if n is even, or if n is odd, x is the n plus 1 and quantity divided by 2. And we represent that median as x with a tilde. Now, I recognize that in your previous math classes, particularly in middle school and high school, this was not how you were taught to think of median. You arranged the values in order, you might have slashed out until you had your value in the middle. This is still the exact same thing. We're just giving it a more sophisticated look to it. What they're doing here is this is the position of your value. And we have to do this theoretically because we're not looking at an actual example yet. So if we think of we have x1, x2, x3, x4, x5. We now have n is odd because we've got 5. To find our median, it is x sub quantity n plus 1 divided by 2. Our n in this case is 5. So that is 5 plus 1 and quantity divided by 2. So that's going to be x sub 6 divided by 2, or x3. That is going to be our median. We can do a similar thing when we have an even number. So I'm going to take a second, and instead of having x1 to 5, we'll have x1 to x6. This is a case where n is even. So we are going to need to do 1/2 x n sub n divided by 2. So that's going to be x 6 divided by 2 plus x sub n plus 1. So that's 6 plus 1 and quantity divided by 2. Simplify. We have 1/2 x3 plus this is what happens when you're using a touchscreen. X 7 over 2. Now we need to simplify again. that'll give us 1/2 quantity x3 plus x 3.5. If we add this together, we have 1/2 x sub 6.5 which will give us x sub 3.25, or 25% of the way between x3 and x4. Now wait a minute, this doesn't seem right. I know, there's a typo. Did anybody catch it? Well, fill you in on a little secret. That typo is right here. It shouldn't be plus, it should be minus. Let's try that again. So this time, we will have 1/2 times the quantity of x3 plus, so 6 minus 1 would be 5. 5 divided by 2 is 2.5. So if we add those together, all right, so that would give us x 3.75. Now, that doesn't seem right either. All right, let's put our thinking caps on. We know there's a mistake. My first guess of the mistake was wrong. Let's think about it a little more logically. So, I know that with an even number of our sample size, our median should be x sub 3.5 in this case. So, what do we need to make that happen? Well, if we're checking out this x n over 2, that seems to be appropriate because we are going to want 1/2 n 3, or rather x3, plus x sub 4. So clearly, we were right the first time in the sense we know the error is here. But now we need to think, what is wrong with that formula? So n plus 1 was not correct, n minus 1 was not correct. Here's an idea. Let's try, instead of plus 1, let's try plus 2. Let's see if that works out. So in that case, we would have x 6 plus 2 and quantity over 2. That would give us x sub 4. Now that checks out, but that might only be in this one case. So let's try it with only x1, x2, x3, and 4. So now we know the answer should be x sub 2.5. Let's try it again with our new formula. So once again, we're going to do x n plus 2. So that will be 4 plus 2 divided by 2. So that will give us x sub 6 over 2, which equals 3. X n over 2 would be 4 over 2, which gives us x sub 2. Add them together, divide by half. Yes, think we got it. Think we fixed it. So the correct formula for when n is even is 1/2 times the quantity x sub n over 2 plus x sub the quantity n plus 2 and quantity divided by 2. Woo! That was harder than expected, wasn't it? Okay, so now that we've established how to get the median, let's move on and do an example to further test. So as you can see, this example's already worked out for us, but hey, let's double check my work. So find the median of 78, 83, 92, 68, and 85. So first off, we'll arrange these values in increasing order. So 68, 78, 83, 85, 92. That checks out. Next, we want to determine the number of data values. There are 5 data values, so n is odd. Since n is odd, the median is going to be our middle number, or 83. So x tilde equals 83. Not bad. Let's do another example. So find the median of 20, 15, 12, 27, 13, 19, 13, and 21. Once again, we will arrange these values in order: 12, 13, 13, 15, 19, 20, 21, 27. After a quick count, we can determine that there are 8 data values, so 8 is even. Since n is even, the median is the average of the 2 middle numbers. So our 2 middle numbers are 15 and 19. Add them together, divide by 2, we get our median. Sometimes the old school way is the best way. Now that we've reviewed mean and median, and we've also talked about box plots and histograms, we now need to bring it back and put it in all together. So, when our distribution of values for a variable is symmetric, that means our mean and our median are going to be approximately equal. I'm going to say that again so it can really sink in. So if we have a distribution of values that are symmetric, think back to our symmetric and unimodel histogram. That means our mean and our median are going to be approximately equal. Specifically, we should find them at the center of our histogram or distribution. Question to you: so when the distribution is skewed to the right, which is going to be larger, mean or median? Got an answer? Well, the answer is going to be mean. Mean is more sensitive to outliers or those unusual values. The median is going to go where the most values are located. Oops, before we move on though, I do want you to recognize, though, when it's skewed left, the opposite is going to be true. This is something important to remember. It might come up on a quiz question or an exam question. It's an easy true-false type question. Okay, so let's talk about spread. So locating the center is only part of our story. Are the data all near the center, or are they spread out? Is the highest value much higher than the lowest value? So to describe data, we must discuss both the center and the spread. We've already had a pretty good idea of center when we talked about mean and the median, but we haven't talked about spread. So, first thing to talk about range is that simple range. Range is the difference between the maximum and the minimum values, or formula-wise, range equals maximum minus minimum. If the age of the guests at a dinner party are 16, 18, 23, 23, 27, 35, 74, then the range is the highest minus the lowest, so 74 minus 16, which equals 58. Percentiles and quartiles. Percentiles divide the data into 100 groups. The nth percentile is the data value such that the n% of the data lies below that value. For large data sets, the median is the 50th percentile. The median of the lower half of the data is the 25th percentile and is often called the first quartile. The median of the upper half of the data is the 75th percentile and is often called the third quartile. The interquartile range. So the interquartile range, or IQR, is the difference between the upper quartile and the lower quartile. We often abbreviate each quartile as Q1 for quartile 1, the median is often represented as quartile 2, quartile 3, 75%, and quartile 4, or 100%. So the IQR is Q3 minus Q1. And again, the IQR is going to measure the range of the middle half of our data. Okay, so now that we finished talking about interquartile range, let's talk about our last visualization that we're going to talk about today, and that is box plots. So box plots are an alternative to histograms for visualizing quantitative data. It's nice for comparing groups, and it's a good representation of our 5-number summary. So the 5-number summary is your minimum value of your data, Q1, your median, or Q2, Q3, and then your maximum data. So box plots are formed by lines at Q1, the median, and Q3, and then whiskers out to the maximum and minimum value. So for example, if we have a data set where our maximum value is 6.73, our Q3 is at 2.28, our median is at 1.12, our Q1 is at 0.46, and our minimum is at 0, we can see that our lines are drawn. Median, Q3, Q1. From there, we draw a box, and then we draw whiskers out to our minimum and maximum values. Again, this is an alternative way of illustrating quantitative data instead of using histograms. It's best when we're trying to compare multiple data sets. Now, to finish up our discussion of spread, let's talk about sample variance and sample standard deviation. The sample variance is a measure of how far the values in a data set are from the mean on average. The sample variance is denoted by S squared. And S squared is equivalent to the summation of the quantity of xi minus x bar n quantity squared all over n minus 1. Now let's take a second to review some of this notation. So our first symbol remember, is our summation, meaning that we are going to add. Xi, that is our arbitrary way of showing each individual observation. X bar, that is our sample mean. And finally, N, remember, that is our sample size. So, in order to find our sample variance, we are going to take the difference of each individual observation, subtract the sample mean, and then with that quantity, we are going to add it to all the other differences of our individual observations and sample means. After each quantity is squared, then we add them all together and then divide by our sample size minus 1. To show you visually in a distribution spread what variance looks like, so low variance has a very small spread. Moderate variance, medium spread. High variance, large spread. Ideally, lower variance is better because smaller spread, more accurate data. Let's take a look at an example. So the following table represents the average monthly temperatures in degrees Fahrenheit for the cities of San Francisco and St. Louis. Now, if we take a look at the data for San Francisco, we can see that all the temperatures are somewhere in the 50s and 60s, where in St. Louis, we have temperatures in the 30s all the way to the high 80s. So that's going to tell us that San Francisco has a smaller spread. The values are going to be closer to the mean. We are going to have a smaller variance. St. Louis is going to have a larger spread, values that are further from the mean and a larger variance. So in conjunction with variance, we have our sample standard deviation. The units of variance are the squared units of our data. So in the temperature example, the units of the data are degrees Fahrenheit. The units of variance are squared degrees Fahrenheit. Now, it's usually easier to understand a measure of spread that has the same units as the data. So this is where our sample standard deviation is. Our sample standard deviation is the square root of the variance. So our sample standard deviation is noted by the lowercase s. So s is going to be equivalent to the square root of s squared, which is equivalent to the square root of the summation of our quantity xi minus x bar and quantity squared, all divided by n minus 1. So just to recap, standard deviation is the square root of variance. Both of these are going to be measures of spread, and both have their pros and cons. Variance is always positive, so sometimes that's helpful, but standard deviation has the same units as what you're currently working with. So if you're working with Fahrenheit, standard deviation is also measured in Fahrenheit. Whereas if you were with variance, it would be Fahrenheit squared. So let's take a look at the procedure for computing the variance. So step 1, you would compute your sample mean. Step 2, for each sample value xi, you're going to compute the difference of xi minus your sample mean. This is called the deviation for the value xi, meaning deviate from your mean. Step 3, we will square all our deviations to obtain the quantities. Step 4, we will take the summation of all our square deviations. Then we will divide our sum by n minus 1 to obtain our sample variance. All right, so using our example, sorry about my fingers slip, a company that manufactures battery is testing a new type of battery designed for laptops. They measure the lifetimes in hours of 6 batteries, and the results are presented in the following table. We're going to try to find the sample variance of the lifetimes. So for the battery life, we have 3, 4, 6, 5, 4, and 2. So using our process, we know step 1, we're going to want to compute the sample mean. So we are going to add up our values and divide by our sample size. So 3 plus 4 plus 6 plus 5 plus 4 plus 2, all divided by 6 equals 4. So our sample mean equals 4. Next, step 2. For each sample value xi, we want to compute xi minus our sample mean to get our deviation. So again, we have our battery lifetimes for 3, 4, 6, 5, 4, and 2. So we are going to subtract each of these observations minus 4, which will give us 3 minus 4, which is going to be negative 1, 4 minus 4, which will be 0, 6 minus 4, which is 2, 5 minus 4 is 1, 4 minus 4 is 0, and 2 minus 4, which is going to be negative 2. That completes step 2. Now, for step 3, we're going to square all the deviations to obtain our quantities. So, from the previous slide, we have our deviations of negative 1, 0, 2, 1, 0, negative 2. Now we need to just simply square them. So 1, 0, 4, 1, 0, 4. Step 3 is probably one of the easier steps. Next, for step 4, we are going to take the summation of all our square deviations. So, adding it all up, 1 plus 0 is 1, plus 4 is 5, plus 1 is 6, plus 0 is 6, plus 4 equals 10. This brings us to our last step. Divide the sum obtained in step 4 by n minus 1. So, n minus 1, we have 6 observations. 6 minus 1 is 5. So, 10 divided by 6 minus 1 equals 2. Our sample variance is equal to 2. That means our sample standard deviation is going to be the square root of 2. Hopefully that wasn't too bad. If not, you may want to consider creating a couple small data sets for yourself to practice. Or you can just do your homework in the quiz. Up to you. Alright, so to finish us off, well, I accidentally already gave away the answer, but we are asked to order the histograms below from smallest standard deviation to the largest standard deviation. Okay, so what do you think? Because I realized I didn't give you the answers. That was just labeled as A, B, C, and D. So, let's think about our histograms for A. What do we know about it? Well, we know that it is very uniform, and that means our data is going to be pretty evenly spread out. So I'm going to say that its standard deviation is going to be about average. Let's take a look at our histogram for B. Now, it is symmetric, but our data lies away from the center. And if you think back to our formula, it is our individual observations minus that sample mean. So that means our largest values are away from our center, meaning we are going to have a standard deviation that is going to be comparatively large. Next, let's think about C. Now, C in some ways is histogram B's opposite. It's symmetric, but it's very bell-shaped, with our data clustered in the center. So that means that our individual observations subtract our sample mean, that difference is going to be much smaller, which means our standard deviation is going to be comparatively small. So if we want to order our histograms from smallest standard deviation to largest standard deviation, our answer is going to be C, A, B. CAB. Not bad. All right, so last slide is our summary slide. So just a couple things to remember. Discrete variables, we use these to be described using bar graphs, pie charts, and frequency tables. Continuous variables, we use graphical summaries such as histograms and box plots. Make sure for those histograms and for the distributions, you know their shape. Symmetric, skewed left, skewed right, unimodal, and bimodal. Make sure you know how to calculate your measures of center and spread, meaning mean, median, range, IQR, and standard deviation. And a big thing, make sure you know the difference between a bar graph and a histogram. Okay, so that brings us to the end of our first lecture video. Again, as always, if you have questions, feel free to send me an email, and have a good night.